I'll just kind of start talking through A. For A, what I'm going to do is I'm going to rewrite each of those in scientific notation first and then enter them on my calculator. So this 50 million, I have one digit, 5, times 10 to the power of, count how many I need to move over. So 1, 2, 3, 4, 5, 6, 7. To the right gives me 5 times 10 to the 7. I'm going to multiply that by, I only have one digit at the end of this exceptionally small number. So I write that digit, move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the left. Oops. So I get 10 times, or 6 times 10 to the minus 10. Okay, and then my number in the denominator, I have one digit, 2 times 10 to the power of, and move it over 1, 2, 3, 4, and that's all going to be cubed. So here's all my expression, all my numbers in scientific notation. If I calculate this, I get 5e to the 7 times 6e to the negative 10. Divide by, now my whole quantity in the denominator is going to be cubed, so I'm going to put that in grouping symbols. So 2e to the 4th, and that whole thing is going to be cubed. And so when I enter this, I get my answer, 3.75 times 10 to the minus 15. All right, for B, this one's already written in that form, so all I need to do is enter it on my calculator. So I have 3 times 10 to the negative 5, so that's 3 negative 5. Times here, this whole quantity is going to be cubed. So since I'm cubing the whole quantity, I do want to put that in grouping symbols. So 6e to the minus 3, all cubed. And then I'm dividing that by, in the denominator, 9e to the negative 12, all squared. Once I enter everything, I can calculate it. It gives me my answer. Here I have 8 times 10 to the power of, and just count how far to the right I need to move my decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right to get my solution. And now, a problem like B is potentially one that you might see and be expected to do by hand. And if you're approaching this one by hand, here's what I would expect you to do. And what I would do is kind of group things together here. So if I'm looking at B and solving this by hand, in the numerator I have a 3 and I have 10 to the minus 5. Next I have this 6 cubed. So the way I'm going to express it is just 6, 6, and 6. But then the 10 to the power of, I'm going to go ahead and apply the rules. So when I take a power to a power, what do I do with the powers? Multiply. So negative 3 times 3 is negative 9, and that's all divided by, here I'm going to square the 9, so I have 9 times 9, and then do the same thing with my 10 to the negative 12 squared. What do I do when I take a power to a power? Multiply. Okay, so in looking at this, what it allows me to do here is to simplify a little bit, because I have this 3 cancels with the 9, leaving a 3. This 3 cancels with 6, leaving a 2. Remember, there's 2 3's in this 9. One of them cancels with this 6, leaving a 2. One of them cancels with this 6, leaving a 2. So across my numerator, I have 2 times 2 times 2. So I have a total of 8 times. And now, if I move this factor of this base of 10 up to my numerator, I change the power of its sign, or change the sign of its power. I now have, multiplying here, 10 to the minus 5 plus a minus 9 plus a 24, or again, I could have left it down here and said minus a negative 24 becomes a plus 24. And if I simplify that, negative 14 plus 24 gives me 10. And so you should be able to do a problem like this without using a calculator.